Hello my dear students. In the last video I explained definition of indexed family of sets. In this video I explain what is definition of union of indexed family of sets, intersection of indexed family of sets, and one important theorem, that is generalized De Morgan's laws. How to define indexed family of sets? We use these letters. It is capital lambda, small lambda. They are Greek letters, and this is the uppercase and this is the lowercase. As in the case of English alphabets, in Greek alphabets also there are uppercase and lower cases. This is capital uppercase lambda, this is lowercase lambda. And indexed sets may be capital N, Z, Q and so on also. But usually we take this as notation. How to define indexed family of sets? Let this capital lambda be any set, maybe non-empty set also. It may be equal to pi also. Let lambda be any set. Then, if for each lambda belongs to lambda, there exists a set denoted by A lambda, then this set of all A lambda, such that lambda belongs to lambda, is called indexed family of sets indexed by this lambda, and this is called index set. It is called index set. Now we consider the union and intersection of indexed family of sets. You know what are union and intersection of two sets? Suppose A and B are any two sets. A union B is set of all x such that x belongs to A or x belongs to B. That means union means if it is either in A or B, then it belongs to A union B. In case of intersection, how we define A intersection B is set of all x, x belongs to A and x belongs to B. So in case of intersection, it is defined like this. A intersection B set of all x, x belongs to A and x belongs to B. That means if x belongs to both A and B, then it belongs to intersection. Now we define what is union and intersection of indexed family of sets. Suppose this is A lambda is indexed family of sets. Now I consider union. First one, union. The union of indexed family of sets, A lambda, lambda belongs to lambda. This also can be used notation. Indexed family of sets, index set is lambda here. It is denoted by union of indexed family of sets is denoted by union A lambda, lambda belongs to lambda, or union A lambda, lambda belongs to lambda. Two notations are there. Usually this is used, or this is also common notation. Say union A lambda, lambda belongs to lambda. It is defined like this. Union A lambda, lambda belongs to lambda is set of all x such that x belongs to A lambda, lambda belongs to lambda. What is the meaning of this? Union A lambda means it is set of all x, x belongs to A lambda, lambda belongs to lambda means if x belongs to at least one A lambda, you know what is indexed family of sets? Indexed family of sets means A1, A2, A3, etc. It consists of A lambda means if index set is 1, 2, 3, etc. Then what are the sets of this family? They are A1, A2, A3 and so on. Now, if x belongs to at least one of these A1, A2, A3, then it belongs to union. So, union A lambda is defined like this. How union A lambda is defined? It is set of all x such that x belongs to A lambda, lambda belongs to lambda. Second, intersection A lambda, lambda belongs to lambda. It is defined as set of all x, x belongs to A lambda, for all lambda belongs to lambda. Can you find any difference here in union and intersection definition? There is a difference here. What do we have defined here? For union A lambda, it is set of all x where x belongs to A lambda for at least one lambda. Then it belongs to union. For intersection, it is set of all x, x belongs to A lambda, for all lambda belongs to lambda. It is intersection. Now, example. So I take the same example that I have already given for you. Example is like this. Let capital N be the index set. Index set. You know what is capital N? Set of all naturals be the index set. And AN be defined as AN be indexed family of sets. AN be defined as, it is defined as all the rational numbers, set of all rationals whose denominator is n. Then what is this? A1 is 0 plus or minus 1 plus or minus 2 plus or minus n, so on. How an is defined? It is set of all the rational numbers with denominator 1. A1 means all the rational numbers denominator 1. 0 by 1 plus or minus 1 by 1 plus or minus 2 by 1 and so on. What is A2? A2 is again 0 by 2 plus or minus 1 by 2 plus or minus 2 by 2 plus or minus 3 by 2 plus or minus 4 by 2, so on. This is A2. Again, what is A3? A3 is 0 plus or minus 1 by 3 plus or minus 2 by 3 plus or minus 3 by 3 plus or minus 4 by 3 plus or minus 5 by 3 plus or minus 6 by 3 and continuous. It is infinite. A4, A5, etc. An is 0 plus or minus 1 by n plus or minus 2 by n plus or minus 3 by n and so on. N is any natural number. N is any natural number. Now, I explain what is the union and intersection of this set. First I take union. Union of A lambda. Now, AN, here n is used. Union of n belongs to n is. Anybody, what is union of n and n belongs to n? Union means it is set of all x such that, how to define? Set of all x such that x belongs to an for where n belongs to n. Where n belongs to n. X belongs to at least one an. What is that? Now here, union of all this is, it is set of all rational numbers. Because union means it is 0, 1 by 2, it is 3 by 2, so on, 1, 2 also it includes. So it is set of all rational numbers. Correct? Set of all rational numbers. What is the intersection? Intersection an n belongs to n is. What is the common elements in all these sets? A1 we have only integers 0 plus or minus 1 plus or minus 2, so on in A1. In A2 also, can you find out set of integers? Yes, we have integers here. 0, 2 by 2 is plus or minus 1. This is plus or minus 1. 4 by 2 is plus or minus 2. And then 6 by 2 is plus or minus 3 and so on. It also includes all the integers. What about A3? A3 also includes all the integers. Because A3 includes 0. What is plus or minus 1? It is 3 by 3. What is plus or minus 2? Plus or minus 6 by 3 and so on. 3 is plus or minus 9 by 3. That means in A3 also we have all the integers. Similarly in AN also we have all the integers. 0. What is 1 here? Plus or minus n by n. 2 is plus or minus 2n by n and so on. Therefore, what is the intersection? Set of all integers. So this is how we define union and intersection. I think this example is clear. The concept is clear. Intersection and union. Now we consider this a particular case. As earlier I told, what is index set here? Index set may be empty set also. So the concept is like this. I take this as known. If index set is pi, then union A lambda, lambda belongs to lambda, is pi. If index set is pi, union A lambda, lambda belongs to lambda is pi. Union of indexed family of sets is pi. This is because, how to define union A lambda? Union A lambda is set of all x such that x belongs to A lambda for lambda belongs to lambda. For at least one lambda belongs to lambda, there should exist A lambda such that x belongs to that A lambda. Then x belongs to union A lambda. Now here, since this lambda is equal to pi, what is lambda? Index set is pi. There is no, there exists, index set is pi. Therefore, there exists no lambda belongs to lambda. There is no lambda belongs to lambda. Therefore, what happens? There is no x belongs to A lambda. There is no x belongs to A lambda means union lambda is pi. So this result is important. In the next theorem we use this. If index set is pi, union A lambda, lambda belongs to lambda is pi, empty set. But however, if index set is pi, intersection A lambda, lambda belongs to lambda is the universal set. This is important. Becomes universal set. Because how to define intersection A lambda, lambda belongs to lambda? It is set of all x such that x belongs to A lambda for all lambda belongs to lambda. X belongs to A lambda for all lambda belongs to lambda. Correct? Now, if lambda is equal to pi, first is, if lambda is equal to pi, union of A lambda becomes empty set. If lambda is equal to empty set pi, intersection A lambda becomes u. Now I explain why it is u. For that, how to prove that two sets are equal? How to prove that two A and B are equal? Here, left hand side one set, right hand side is universal set. These two sets are equal. This we have to prove. How to prove that two sets are equal? We prove that A is contained in B, B is contained in A. Then A is equal to B. How to prove that A is contained in B? We take an arbitrary element x belongs to A and we prove that x belongs to B also. Then A is contained in B. Similarly, we have to prove that B is contained in A. Now, first we prove that intersection A lambda, lambda belongs to lambda contained in U, and U is contained in intersection A lambda. First we prove that U is contained in intersection A lambda, lambda belongs to lambda, lambda is pi here. Understand? We have to prove that intersection A lambda, or we prove that intersection A lambda, lambda belongs to lambda is U. What is U? Universal set. For that, we prove that intersection A lambda is contained in U. U is contained in intersection A lambda. First, we prove that U is contained in intersection A lambda. For that, let X be any arbitrary element of U. Any arbitrary element of U. What we have to prove now? We are proving U is contained in this. For that, we take X be any arbitrary element of U. Also, X belongs to intersection A lambda, lambda belongs to lambda. If X belongs to A lambda, for all lambda belongs to lambda. See the definition of intersection. When X belongs to intersection A lambda, X belongs to A lambda, for all lambda belongs to lambda. But here the interesting thing is, but there are no lambda belongs to lambda. When X belongs to intersection A lambda, if X belongs to A lambda, for all lambda belongs to lambda. Now, since there are no lambda belongs to lambda, this for all lambda belongs to lambda is satisfied. Therefore, X belongs to intersection A lambda. I repeat once again. When do you say that X belongs to intersection A lambda? Definition: if X belongs to A lambda, for all lambda belongs to lambda. But here, this capital lambda is a null set or empty set. This for all lambda belongs to lambda is satisfied because there is no question of lambda belongs to lambda. It is satisfied. So what happens? X belongs to intersection A lambda. Now, therefore, X belongs to U implies X belongs to intersection A lambda. Therefore, U is contained in intersection A lambda, lambda belongs to lambda. What is lambda here? Index set, null set. Now, what is U? Universal set. What is meaning of universal set? Universal set means all the sets which are in discussions are subsets of that set. That is called universal set. Therefore, this intersection A lambda, lambda belongs to lambda, is contained in U because this is the universal set. Now, therefore, what happens from these two? Intersection A lambda, lambda belongs to lambda is equal to universal set. So, these two results you have to remember always. What is the first result? If the index set is pi, then union A lambda, lambda belongs to lambda is, what is union A lambda, lambda belongs to lambda? Pi. If index set is pi, intersection A lambda, lambda belongs to lambda is U. Now, generalize De Morgan's laws. Generalized De Morgan's laws. I give the statement of this, and proof may not be possible in this video because I earlier only I told only I can do the video of 23 minutes. 23 minutes. Now, what is the generalized De Morgan's laws? Suppose A lambda, lambda belongs to lambda. A lambda, lambda belongs to lambda, be the indexed family of sets. Then union A lambda, lambda belongs to lambda, complement is, it is intersection A lambda, lambda belongs to lambda. It is intersection of A lambda dash, or I write like this: union A lambda, lambda belongs to lambda, its complement is intersection of A lambda complement lambda belongs to lambda. You can see the difference here. In union A lambda whole complement, it becomes intersection of A lambda complement, and intersection of A lambda, lambda belongs to lambda, its complement is union of A lambda complement, lambda belongs to lambda. This is called generalized De Morgan's laws. Here, what is this capital lambda? Index set. It may be empty set also. There are two cases: lambda is empty set or lambda is non-empty set. Now, what is this De Morgan's laws? For any two sets, A union B is A dash intersection B dash. Correct? What is A intersection B dash? A dash union B dash. This is for any two sets, De Morgan's laws. But this is for family of sets. This is called generalized De Morgan's laws. I explain proof of this in the next video. You go through all the videos, and also as earlier I give the PDF notes of this also. So go through this. If you have any difficulty, you can contact at any time. Okay, thank you.